Okay, in a bit here I'll do section 3.5. I wanted to do a couple review problems because I know these things could make it on the test, and some of them we haven't done for a while. So let me make up 3 quick graphs just to get you practice in finding the domain and range from a graph, because these will definitely make their way onto the test, and they're the kind of problems that you can't get a lot of partial credit for. They're either, your answers are either right or wrong, and they're usually nothing between. So I don't have graph paper handy this morning and my computer network is down. This video operates outside the computer network for whatever reason, at least temporarily does, until I sync them up. So I can record a video, but I can't print out more graph paper. So if this was a question on the test and I was asked to find the domain and the range, there's no equation, so there's no algebra to do. And because the points aren't connected, it's wrong to connect the points. When you write the domain and the range, you just pick off the x and the y coordinates of the points, and you write the domain and the range with the little squiggly set braces. So it's real common for students to connect the points, but you don't know. I mean, just because it looks like you can connect the points, you don't know the correct way to connect the points, because there isn't a correct way. You can connect the points by coming way up here and way down there, or you can connect the points efficiently, but it's wrong to connect points to find the domain and the range on a graph that doesn't have the points connected to start. So I just picked off the x coordinates of the 3 points that I wrote and called that domain, and I'll do the y coordinates and call that the range. And when the points are disconnected, when I write the domain and the range, I use the squiggly set braces and I write every individual x coordinate and every y coordinate. And that's all there is to do for this particular problem. I think I can squeeze another problem right on this page. So same question, find the domain and the range, but unlike the last problem, the graph you're given, the points are connected. And, nicer yet, the edges of the graph have periods. When you're given a graph like this and you're asked to find the domain and the range, then your answers are going to be intervals. And if my intervals don't have infinities, generally we have square brackets. We could have round brackets, but for this style of problem, the domain and the range are going to be square brackets. To do the domain, I have to identify the most left point and its x coordinate, and the most right point and its x coordinate. And I write the domain with just the 2 numbers, -1 and 5, separated by a comma inside square brackets. For the range, I need to pick off the point that's at the bottom and its y, and the point that's at the top of the graph and its y. So the bottom point, the lowest point on this graph is the point -1, -2. Its y is -2. That belongs in the range. The point that's at the top of the graph is the point 3, 4, and its y is 4. It belongs in the range. So the range is going to be -2, 4, square bracketed. Let me do one more domain and range problem, and then do something out of 3.3 that I haven't reviewed yet. So here's another graph problem. So this will start to look a lot like the last problem that I did, but it's different. So if this was a test question, I said find the domain and the range. Because the given graph doesn't have the endpoints labeled, then it's implied that I need to extend the graph in the direction that it's going. So I'm going to extend it down and to the left. It goes to the far left edge of the x-axis and the bottom of the y-axis, so it extends to the double negative infinity. And it extends down and to the right. It goes to the far right edge of the x-axis, which is the positive x direction, and the bottom of the y-axis. So when the edges of the graph aren't marked with a period, any edge of a graph that's not marked with a period, it needs to be extended to some infinities. So now that I've extended this graph to this point is going to be the most left point. This point's going to be the most right point. And the domain, when we have a graph that has connected points, we write the x-coordinate of the most left point, then the x-coordinate of the most right point. Usually you put round brackets around the infinities because we don't really get to infinity. It just implies the graph goes on forever without stopping. If you put square brackets, it means you can actually get to infinity, but that's really over technical. It's not that big of a deal. If you put square brackets, I wouldn't take points off. For the range, I have to decide which point is at the bottom. It turns out that it doesn't matter if you called this point the bottom or that point the bottom. It looks like this side's going down a little bit quicker, but ultimately they both get to the bottom of the y-axis, and they both have the same y-coordinate. So it wouldn't matter which one you call the bottom when you're finding the range. The y-coordinate of the bottom point is going to be negative infinity. And this point up here is going to be my top point. And when I go to write my range, I'm going to say the y-coordinate of the bottom point is negative infinity. The y-coordinate of the top point is 4. Usually infinities get square brackets, and points on the graph, infinities get round brackets, points on the graph get square brackets. So that's a little review of section 3.2. I wanted to do a problem from section 3.3 that I hadn't done a review of. So below is a graph of the function f of x. Again, this is not from the handout. This is just reviewing something that I know will be on the test, or that might be on the test. Sometimes I change my tests from semester to semester. I think it's adequate. Could label more points, but I'm not gonna. Try to keep this as simple as I can. So here's a nice graph that ends here and it ends here. It doesn't extend on forever. The kind of question that you might be given on the test will be this. And these are two separate questions. So neither one of these questions are going to require algebra because I don't have any x's or y's to plug any numbers into to do algebra. So I have to understand what the question is asking for. Each one of these questions calls out an x or a y value on of a point on the graph, and it wants me to kind of find the other part of the point. In this top problem, because the 3 is in a parentheses, numbers in a parentheses stand for x values, and this problem is asking me to find the y value that corresponds to x equal to 3. And for an answer, I can write f of 3 equals to 0, or if you want to, you can write y equal to 0. The second problem on this page, because the number that's given is to the right of an equal sign, that number stands for a y, and it's asking me to find an x. For an answer to this one, I could say x equal to 2, or I can say f of 2 equals to 3. Let me make up one more like this, and maybe, yeah, I'll just make up one more like, I'll make up one more like this and add something to it. It's a little bit harder without graph paper. I'm kind of not happy that my computer system is down this morning, but it's 6 a.m. on a Sunday morning, so maybe they're doing something. So I'm making lots of points. It's going to make this a little bit harder. I'm just completely making this equation up. So from this graph, let's call this is the graph of a function called g. And let's just make a problems 1. Find g of 3. 2, find all values of x such that g of x equals to 3. So these are kind of parallel questions, or the same questions that I asked for the last equation, or last picture. The first one, because the 3's in a parentheses, it stands for an x value, and it's specifically calling out the point 30, and it's asking me to find the y value. So for this one, for an answer, I can say g of 3 equals to 0, or if I want to, it'd be equally correct to say y equal to 0. The second question that I wrote on this sheet of paper, the 3 is to the right of an equal sign, so it stands for a y, and it wants me to find the x's that pair with that y. For the second one, I have 2 points that I drew that had x's equal to 3, and that means I had y's equal to 3. I have 2 x's to give for an answer. So for my answer, I could just say x equals -1 and 2, or I can get, more precise, I guess. I could say g of 1 equals -3, and positive 3, and g of 2 equal to 3. So that's the tricky part. It seems to me like I might have actually asked a few more questions about a graph on the test. So try to do these 2 questions. Find the x-intercept, or seps. I don't have room to write intercept, so I abbreviate it. And find the y-intercept. And there can't be any algebra because I don't have an equation for the function. So for the first new question, to find the x-intercept, I look at the x-axis, and any point on an x-axis is considered an x-intercept. So for this particular graph, the x-intercepts are the points -2, 0 and +3, 0. To find a y-intercept, I look at the y-axis, and any point on the y-axis is a y-intercept. So the y-intercept here is the point 0, 4. So any of the things that I just did, specifically finding the domain and the range of a graph that's listed as a set of points, finding the domain and the range of a graph where the points are connected, that the endpoints are labeled, that doesn't need to be extended, finding the domain and the range of a graph where the endpoints aren't labeled, that has to be extended, using a graph to find x and y values given function notation, using a graph to find x and y values giving function notation, and finding the x and y intercepts are all things that might make their way onto the test. So they're all things that you should be able to do. And what these problems have in common is there wasn't any algebra that I did for any of these problems. And when those types of problems make their way onto the test, I just can't give a lot of partial credit. So these are super important problems to just, bust out perfectly. If I had to guess, there's probably 1, 2, 3, 4, 5. I don't know. This is probably 20 to 25 points on the test. So maybe a quarter of the test could be just from doing these sorts of problems that either you kind of get them right or you don't. Alright, so I'm going to attempt to do section 3.5. And in section 3.5, it's a word problem section. It's not the worst word problem section that we ever do. But it does have new words, and that's the thing that makes it challenging. If it's going to seem challenging, it's just because you'll hear words that you haven't heard before, or you maybe have heard the words but don't really know how to express those words mathematically in terms of equations. So I made up a little, typed up a little summary of the words in this section. So the first words I might see in a question is the words varies directly or directly proportional. Kind of the key word that connects these is the word directly. And anytime I see the word varies directly or is directly proportional, I translate the words varies directly to is some number times. Or I translate the words directly proportional to is some number times. So directly, if I see directly, I think it's is some number times. So if I just saw these words, y varies directly as x in a problem, immediately I would change the word varies directly to y is some number times x. So y varies directly as x, the y and the x kind of stay, the varies directly as turns into is some number times. If I was asked to write an equation or an equation to represent this statement or that statement, the letter y I would leave as the letter y. The is, I'd make an equal sign. And I can't use an x for some number, although I'd like to, but x is already in the problem. In a lot of these problems, there's already an x there. Usually in the style of problems where you have varies directly, directly proportional, use k for the sum number. The k won't come up again in the problem usually, and it's a safe letter to use for the sum number. So for the sum number, I'm going to use the letter k. And then times, I don't need a times symbol. If I write two letters next to each other, that implies times. So the words varies directly as x has the same meaning as y is some number times x, and is equivalent to the equation y equals kx. Similarly, if I saw the words y is directly proportional to x, I'd think the same statement. I would think y is some number times x, because directly proportional and varies directly can be used, you can interchange the way you use them. And as an equation, the equation would be the same then, y equals kx. The next two words or pairs of words that I might see in a problem in this section is the word varies inversely or is inversely proportional. And what links these two little statements or pairs of words is the words inversely. And mathematically, when I see inversely, I think divide. So directly, I think multiply. Inversely, when I see those, I think divide. And very specifically, if I see the words y varies inversely as x, or y is inversely proportional to x, the word varies inversely I change to is some number divided by. Either I physically write that down or I just think of that in my head. So if I saw y varies inversely as x, immediately when I see the word inversely I think divide, and the sentence that we'd be more used to seeing without the word inversely that has the same meaning is y is some number divided by x. Generally, when I see inversely, I form a fraction to show the divided by, and the sum number, the k, is in the numerator. So this statement, y varies inversely as x, means y is, so I'd write the letter y, is for equals, the sum number is the letter k, and I show the divided by as a fraction. That would be, for both of these, y is inversely proportional to x actually has the same meaning. It's y is some number divided by x. And an equation would be y is, which is equals, some number, which is k, divided by x, and x goes in the denominator. So directly is one of the new words that we're going to see in this section, and it implies multiply. Inversely is another word we're going to see in this section. It implies divide. There's another word that implies multiply, but it's slightly different in that for directly, there's one thing we're multiplying by the sum number, or one thing we're multiplying by the k. The third word we're going to see in this section is jointly. And varies jointly is also a word that translates to multiply, but it's multiplying by two things after the k. So when I see the word varies jointly, like if y varies jointly, as soon as I see varies jointly, I know that there's going to be two letters after the word varies jointly, and I know that varies jointly means to multiply, but instead of multiplying by one letter after the sum number or after the k, you multiply by two. So if I saw y varies jointly as x and z, I'd think of that as y is some number times the product of x and z. And as an equation, the y is the letter y, the is the equal, the sum number is the k, and then the product of x and z, I'm just going to multiply x and z after the k. I don't need any parentheses to show that multiplication. So y varies jointly as x and z as an equation would be the equation y equals kxz. It may feel a little complicated at first because we're not doing any problems yet, but once we get into the problems after we've done 3 or 4 problems, you'll probably get to feel real comfortable with these words, and the section won't seem intimidating. There are a few other words that you should be familiar with, but you might not be familiar with, that you're going to need when we do the section itself. If I saw the words the square of x, Square implies an exponent of 2. So if I said the square of 9, we'd write 9 squared. 9 squared is 9 times 9, which is 81. So square implies exponent. Square root implies the square root symbol. So if I saw the square root of x, I'd want that symbol. And then, for example, the square root of 9 would be written with the square root symbol as opposed to an exponent. So square, I get an exponent. Square root, I get the radical symbol. And on this calculator, to do the square root of a number, it's easy. There's a square root key. I would just hit the square root key, type whatever number I want to take the square root of, and I could get that. Third thing I might see is the cube of x. Cube, like square, implies an exponent. The cube of x is an x with an exponent of 3. If I wanted to find the cube of 8, that would be 8 to the third power, which is 512. On this calculator, if I wanted to do a cube, I would just hit this x with the square key, with the x, the square, not the 2, but the square, and I'd go 8 to the third power, and that would tell me it's 512. And then something else that comes up in this section is the cube root. A cube root, like a square root, you need a radical symbol. Cube root, you usually have a little 3 with a radical, and this cube root asks me what number times itself 3 times is a number under the radical. If I wanted to do the cube root of 8, we'd put 8 under a cube root symbol. On this calculator, to do cube root of 8, you'd hit the shift button and then the square root key. It gives you a cubed root, and then you can type the number 8, and it tells me the cube root of 8 is 2, because 2 times itself 3 times is 8. So that's all the review we need for this section. Now I'm going to get into the first few problems. The first section of problems gives me, all it gives me is a statement, and it wants me to take that statement and change it into an equation. So problem 2 gives me the statement a varies directly as the square root of b, and it wants me to take that sentence or sentence fragment and change the words to symbols. And what I did when I typed this up is because I knew I don't write so well, I knew what I was going to write. I parenthetically, under the problem, wrote what I think. So when I see the word varies directly, I change the word varies directly as to is some number times. So immediately, when I was going to do this problem, I changed the word varies directly to is some number multiplied, which is the same as times. So I left the AA, I changed varies directly as to is some number multiplied by, and then I left the square root of b alone. So either the initial sentence that's given or my rewrite of it, they're equivalent to each other, need to be changed into an equation. And I'll do this bottom one. The letter A, I'm going to leave the letter A. The is, I'm going to write as an equal sign. The some number multiplied by or some number times, I'm going to write K. And then the square root of B, because it's square root, I'm going to put the B under this radical symbol and not give it an exponent, because square root implies I need that symbol. Square root of x would mean x under the radical. Square root of b would give me a b under the radical. And that's absolutely all there is to do for problem 2. I just want us to get used to changing equations or sentences into equations. You don't have to do what I did parenthetically there, although it's not a bad idea to do it. So I'm going to do the same thing for problem 4 when I get to it. So 4 gives me a statement that says z varies inversely as the square of y. And immediately I can write an equation for that because I understand what varies inversely's equations look like. But if you don't, you can change the word varies inversely to is some number divided by, and that's what I did parenthetically under my problem. So even though it's not given, the word varies inversely as can be changed to is some number divided by. And then I left the rest the same. I left the z, I left the square of y, the square of y. I just changed the words varies inversely to is some number divided by, because on that little handout at the beginning of this section, that's one of the things I said. I said if I see the word varies inversely, I translate it to is some number divided by. So immediately when I saw the word inversely, I knew I can dump out that part of the problem, change it to is some number divided by, and then leave the rest of the problem, the z and the square of y, intact. So now I'm going to write this as an equation. The letter z I'm going to write as the letter z. The is I'm going to make an equals the sum number divided by. The sum number I'm going to make a k. The divided by I'm going to make a fraction symbol. Usually when we have varies inversely, we make a fraction with a k in the numerator, and I'm sure on that little thing that I typed up, I said that because I'd be surprised if I didn't. And I said, form a fraction with a k in the numerator. So varies inversely goes to divided by, and generally when we're making an equation, we make a fraction with a k in the numerator. I'm going to be completely consistent with that. So varies inversely, z came first, it goes to the left of the equal sign. I get a fraction with a k in the numerator, and after the fraction I get the square of y. Because it doesn't have root, I'm going to have an exponent of 2. So I'm going to get y squared. Problem 6 I'm changing from this semester to from the last time I did the videos. Was going to type this up, but since I can't access my files, I didn't type it up and I just wrote it up. But yours should say that when I actually can get into my computer network. So I made another inversely. So immediately when I see inversely, I know I need to make a fraction. If I want to, I can think of this as y, or w, is some number divided by, because inversely I changed to some number divided by. And what is it divided by? The cube root of x. So this you don't have to do. You don't have to take the initial problem and change it into words that you might be more comfortable with. As long as you know that inversely, when I see the word inversely, I'm going to form a fraction with a k in the numerator, you're probably going to be okay. So the first letter I see is w. I'm going to write it first. For the word is, I'm going to make an equal sign. It's supposed to be some number here. I forgot the number part. For the sum number, I'm going to use the letter k. And generally, when I have varies inversely, I form a fraction with a k in the numerator. And in the denominator, I need the cubed root. And once I see the root, I know I need a radical symbol. And since it's a cube root, I put a little 3 with the radical symbol. My calculator kind of does the 3 a little bit differently. Usually, you put the 3 right in this cup, but it makes the little little check so small that I can't fit the 3 in there. But by hand, you'd usually put the 3 in the little check. And then it's the cube root of x. And so that's all there would be to do for problem 6, is just to create an equation, just to show that I know how to make those words into an equation. 8's a varied jointly. Same deal with 8 as the rest of the problems. The problem initially doesn't have words that I might be used to, but I know that jointly is a word that means multiply. The difference between directly and jointly is directly, there's only one letter I'm multiplying after the k. Jointly, I'm multiplying 2 numbers after the k. So if we go through the words that we have, directly and jointly are multiplied. Directly is 1 letter after the k, jointly is 2 letters after the k. Inversely implies divide. You form a fraction with the k in the numerator. So when I go to do problem 8, I see the word jointly, so I know I'm not getting a fraction. I only get fractions when I have inversely. jointly implies I'm going to have two letters after the K, and I can see what letters they need to be. They need to be an X and a Y, but the Y has to be under a square root symbol, but the X doesn't. So I parenthetically changed the varies jointly to is some number times, just because that's what I'm thinking when I see jointly. And if I want to make an equation out of that, the first letter I see in the problem is B. And then for the is some number times, the is my equals, the sum number is K, and it's going to be times. I don't need parentheses because when I have letters next to each other without symbols, times is implied. So it's going to be times X, and the X doesn't need an exponent or a radical symbol because there aren't any words before the X that imply it needs a radical or an exponent. But the words before the Y implies the Y needs to be under a square root symbol. So that would be setting up 8 the best I can. Again, if you get stumped on what to do with the letters, everything that there is to do with the letters in this section, either I have squares, square roots, cubes, or cube roots. Squares and cubes without the word roots, I'm getting exponents. The word roots, square roots, and cube roots, I'm getting radical symbols, or little kind of check marky division kind of almost looking symbols. So the first 8 problems, that's all there is to do. I'm just taking the words, creating an equation, and stopping. The next group of problems, the instructions say find the constant of variation, and they're 2-step problems. And I'm doing one of the odd ones just because it has the instructions next to it. So the difference between the first 8 problems and the middle group of problems 9 through 14 is I see some numbers. What I'm supposed to do with these problems is first create an equation with a K. So for 9 through 14, first I'm going to create an equation with a K. And then I'm going to plug the numbers in and solve for K. And my answer is just going to be K equals. Even though I needed to create an equation to figure out what K is, the question only wants us to find the K. It says find the K. Sometimes we call K the constant of variation because within a specific problem, K doesn't change. So for this problem, Y varies directly as the square of X. The beginning problem right here, that sentence is supposed to help me come up with an equation with a K. And underneath it, parenthetically, if you needed a push, I know that if I see varies directly, I know it's multiplied. So the equation implied by what I just boxed there is Y equals K times the square of X. I don't see a root, so that square is going to be an exponent. So that beginning part of the problem translates to that. Helps me get my equation, but it doesn't give me my answer. Now I'm going to get the answer by plugging in the numbers that are given. And the numbers that are given is 45 for Y and 3 for X. So I need to solve that equation for K. I best do the exponent first. When you square the 3, you get 9. And it looks weird to have that 9 after the K. I'm going to write it before the K. And now I'm going to divide both sides by 9. And then 45 divided by 9, I don't need my calculator for. I get 5 equal to K. So my answer is going to be K equals to 5. 10's going to work exactly the same way. So when I look at 10, the beginning part of this is what I need to those words I need to come up with an equation that has a K. Immediately when I see varies directly, I know it's going to be a multiply as opposed to a divide. So I don't really even need to do this parenthetical comment. If I get comfortable with that directly is multiplied, jointly is multiplied, but there's two letters after the k, inversely is divided with a k in the numerator of a fraction, then I don't need to do this little parenthetical comment. So this sentence, m varies directly as the square root of y, varies directly as a multiplying. It's for the varies directly part, I need a new letter, k, and for the y, I'm putting it under a square root symbol. And now I'm going to plug the numbers in. The number I'm going to plug in for m is 12, and in for y is 16. I know that the square root of 16 is 4, but if you don't know the square root of 16 is 4, you can do it on your calculator. The square root of 16 asks me what number times itself twice is 16, and that answer is 4. So I can rewrite the right side without the square root symbol, and I'd probably write the 4 to the left of the k, although you could leave it after the k if you really felt the urge. Now I'm dividing both sides by 4. I'm getting 3 equal to k, and that's my answer. And it doesn't matter if you have the k to the right or the left of the equal sign, just I want to know what k is equal to. I suspect I'll just do the rest of the even problems and save you the odd problems. So immediately for problem 12, I notice the word varies inversely. When I see the word varies inversely, I know I'm going to make a fraction with a k in the numerator, and then I'm going to shove the numbers in. So z varies inversely as x. There aren't any words to tell me that the x needs a radical symbol, nor any words to tell me it needs an exponent. So this little thing that I boxed is just going to be z equals k over x. Because varies inversely, you need a fraction with a k in the numerator. Usually, I solve varies inversely problems by cross-multiplying. You don't have to, but it's a good thing to do. We did a lot of cross-multiplying recently in Chapter 2. So if you're working ahead of me, I gotta spell cross-multiplying. That's not a good thing this morning. I think that's spelled right. Usually I just try to write really sloppy when I can't spell something. So I'm going to solve this by cross-multiplying. Very specifically now I'm going to put in 20 for x and 4 for z. I'm going to get 4 equals to k over 20. And it's real tempting to put 5 in for an answer because 20 divided by 4 is 5. This is a dividing problem. That's not the right answer. 80 is actually the right answer. So I'm going to force myself to do a little bit of algebra by writing the 4 as a fraction, putting it over 1, and that sets me up for cross-multiplying. I'll multiply up and get 1 times k, and I'll cross-multiply down and get equals 4 times 20, and then that'll give me k equals to 80. And that's the whole answer to problem 12. Problem 14, the beginning part of it helps me come up with an equation. Because I see the word jointly, I know it's not a divide because inversely is the only one that gives me a divide. Jointly, I know it's a multiply, but there's 2 letters after the k. So the first letter I see in the problem is n. I'm going to write it first. I'm going to have a k for my extra letter, and then after the k I need something for y and the square of x. The y doesn't have any words preceding it that tells me it needs an exponent or a radical symbol, so I'm just going to get a single y. And for the square of x, I'm going to get an x with an exponent. Now I'm going to shove the numbers in. I'm going to put 54 in for n. I'm going to leave the k alone. And for y, I'm going to plug 2. I'm going to put it in a parentheses to signify the multiplying, to somehow separate the y from the x. And then for the x, I'm going to plug in 3. And now it's just completely orders of operations. The first thing I should do is exponent. And on the right side, the only exponent I see is 3 squared. 3 squared is 3 times 3, which is 9. And then I'm going to multiply on the right side the 9 and the 2 and get 18. And then I'm going to divide. I divide 54 over 18. I think it's 3. I do 54 over 18 on this calculator, I get 3. So the answer is going to be 3 equal to k. A few of the answers in the homework will be fractions or decimals, but most of them are just going to be nice numbers. The next group of problems, 15 through 20, are 3-step problems. And the instructions just say solve. So the steps are: first, create an equation with a k. And then second, use the first set of numbers, or first group of numbers, to solve for k. Both of the first two steps we've just been doing. And then third, use the last group of numbers to answer the question. And then the only thing I'm going to write for my answer is the third step. The first two steps, I'll need them to get to my last step, but they're not going to be the answer. So, first thing I see in problem 15 is y varies directly as the cube of x. So I'm going to create an equation for that. Varies directly as multiply, only one letter after the k, and after the k I need a cube of x, which is an exponent of 3. So my step 1 for this is going to give me y equals k times x cubed. Second sentence, I'm going to plug in 24 for y and 2 for x and solve for k. So I've done my first step. I've created an equation with a k. Second step, I'm going to plug in 24 for y and 2 for x and solve for k. So I'll use the numbers, the first group of numbers, which is 24 and 2, to solve for k. This simplifies to 24 equals to 8k. So I did first step. This is my second step. I get 3 equal to k. I'm not done yet. I'm done with the second step. Now I'm going to go to the third step. Find y when x equal to 5. So into my equation, I'm going to find y when x equals 5. I know that k for this problem is 3 and that x is 5. So I plugged in the last number 5 for x and 3 for k, and this is my third step, and whatever this comes out to be, which I think is 375, will be my answer. So I'm doing 3 times 5 cubed, using my calculator to be mindless. I get 375, because this is 3 times 125 if you need, because 5 cubed is 125. So the answer to problem 15 is my very last step. It's just y equal to 375. Do the same for 16. First step, come up with an equation for k. Then use the first group of numbers to solve for k. And then use the last group of numbers to answer my question. And because x is negative, I'm going to have to be really careful with my parentheses and where I put the exponent. So first sentence gives me an equation with a k, directly so it's multiplying. After the k, I need something for the square of x. That's an x with an exponent. Second sentence, I'm plugging in 54 for z and 3 for x. So I'm going to go 54 equals k times 3. It doesn't matter when the x is positive whether I put the exponent in or outside the parentheses. But when the x is negative, if I don't put the exponent outside the parentheses, I'm going to get the wrong answer. So I've been lazy because it doesn't matter when you're squaring a positive number, you're going to get positive with where I put the exponent. So I'm not done yet. I'm only on the second step, getting my answer for k. So first step, came up with an equation with a k. Second step, I used the first set of numbers to solve for k. Third step, use the equation and the last number that I'm given. So I'm going to go z equals, in for k into the formula, I'm going to plug 6. In for x into the formula, I'm going to plug -2. If you have the 2 inside the parentheses, you're going to get a negative answer, and it's going to be wrong. You'll get -24 as opposed to +24. On my calculator, if I did this, I'd go 6 times -2 squared. It would give me +24, which is the correct answer. If you did this, 6 times -2 squared like that, and didn't put the 2 outside the parentheses, you'd get -24, which is the wrong answer. So it usually, you can be lazy about where you put the exponent when you're squaring something, but if it's a negative number, the squaring has to go outside the parentheses. If you put it inside the parentheses and you do it with your calculator, you'll get the wrong sign on your answer. So the answer to 16 is z equal to 24. That's the only thing I'd write in my answer to problem 16. First step, come up with an equation with a k. Because it says inversely, I know I need a fraction with a k in the numerator. So this first sentence, I'm going to write as m equals k over the square root of n. I usually solve by cross multiplying, so I'm going to probably do that. Second sentence has 15 for m and 9 for n. So I'm going to solve that by cross multiplying. I'm going to write the 15 as a fraction. I'm going to write it as 15 over 1. And the square root of 9 I don't need my calculator for. But if you need your calculator, you just hit the square root button right next to the fraction key, type the number 9. That gives you, that's 3. And now I'm going to cross multiply. So first step done. Second step almost done. I'll go 1 times k equals 15 times 3. Don't need my calculator, but you could use your calculator. That gives me k equal to 45. So I'm done with the first sentence, done with the second sentence. Now I'm going to find m when n is 16. So I'm going to go m equals k is 45 over n. This is going to be a fraction answer over the square root of 16. So I took the 45 that I found out that k was equal for this problem, the 16 that I was asked to plug in for n. I'm going to get 45 over 4 because the square root of 16 is 4. If you needed to do this on your calculator, you'd go fraction 45 over square root of 16. My calculator would tell me that's 45 over 4. If you wanted a decimal answer, you could hit the SD button. It tells me that's 11.25. But I prefer fractions to decimals, and the calculator naturally wants to give me a fraction anyways, which is a good thing. So the answer to 18 is just going to be 45 over 4. 20 is the last problem in this grouping. Works just like the rest of the problems. I snuck an A in here. It looks like an So again, first sentence, I'm going to come up with an equation with a k. Because I see the word varies jointly, I know I need 2 letters after my k, and it's all multiplied. And the 2 letters that I need are a and something for the square root of c. So the a, because there's no words before the a that tell me it needs an exponent or a radical symbol, I'm just going to write a lonely a. And for the square root of c, I'm going to write a c under a radical. Next step, I'm going to take the numbers 65 and 9 and plug them in. 60 for B. I'm leaving K alone. 5 for A. 9 for C. I put the A in a parenthesis to make the multiplication stand out. I'm going to do the square root of 9, which is 3. So I can write this as 60 equals K times 5 times 3. And 5 times 3 is 15, so I get 60 equals to 15K. And then I divide by 15, divide by 15, and I think that's 4, but I can do that on my calculator. It exactly is. So I get 4 equal to K. So I use the first sentence, the second sentence, and now I'm going to use the last sentence. The last sentence wants me to find B when A is 4 and C is 16. So I'm going to go B equals, in for K I'm going to plug 4, in for A I'm going to plug 4, and in for 16, for C I'm going to plug 16. So I'm going to go K4, A4, C16 and do this. I could do this all on my calculator, or I could do it in my head. So this is going to be 4 times the square root of 16. I don't need the square root of 16 in a parentheses, but I could. But the square root symbol separates the 16 enough from the 4 so that I don't need it. And I get 64 because this really is just 4 times 4 times 4. And the answer is going to be B equal to 64. The rest of the problems look a little bit more intimidating, but they're not. The rest of the problems are longer word problems, but each one of them is just a 3-step problem where I come up with an equation for a K. I use the first set of numbers to get a value for K. I use the last set of numbers to answer the question, and the answer is going to be what I get on my last step. So this looks way more complicated, but I'm just going to take one sentence at a time. The first sentence is going to help me get a value for K. All right, it's going to help me get an equation with a K, but not a value for K. So as I look at that first sentence, I look for keywords to tell me whether I'm multiplying or dividing. And the keyword in problem 22 in that first sentence is the word inversely. So I'm staring at the first sentence. I see the word inversely. I know I'm going to need a fraction with a K in the numerator. And I was kind, and I gave you the letters you need to use. I needed a letter to represent the number of days and a letter to represent the number of workers. As I scan through that first sentence, I don't see any words like square, cube, cube root, or square root. So I know I don't need any exponent or radical symbols. So the equation I'm going to get from the first sentence, the number of days, it varies inversely to the number of workers, is just that simple equation. D equals K over W, with nothing else needing to be done because I don't need any exponents and I don't need any radical symbols. Now I'm going to go to the second sentence. The second sentence tells me a building can be painted in 2 days with 5 workers. I'm going to use the numbers in the second sentence, plug in 2 for the number of days, plug in 5 for the number of workers, and that's going to help me solve for K. I'm going to solve by cross multiplying. So I'm going to make the 2 a fraction. I'm going to go 2 over 1 equals K over 5. I'll cross multiply up and get 1 times K. Cross multiply down and get 2 times 5. So I get K equal to 10. Now I'm done. So I've finished up my first sentence, finished up my second sentence. Now I'm going to answer the question, how long will it take to paint a building with 8 workers? I'm solving for days. In for K, I'm going to plug 10. In for workers, which stands for W, I'm going to plug 8. That's my answer. That reduces to 5/4, which is 1.25. So I could do lots of answers. So the answer is going to be 5/4 days. And that to me is almost odd. If I hit the SD button, it says 1.25 days or day and a quarter. I'd live with anything, but 5/4 days would be completely fine for an answer, or 1.25 days would also be good. This is one of the rare instances where maybe the decimals answer makes more sense than the fraction answer. I don't think anybody would ever say it's going to take me 5/4 days, but you might say it takes me 1 1/4 days or 1.25 days. But I'm not going to be picky. Usually I like fraction answers. If you give me a fraction answer, it's okay. So 24, same steps as I just did. First, I'm going to look at the first sentence. I look for keywords to tell me whether I'm multiplying or dividing. The keyword is the directly, so I know when I come up with my equation, it's just going to be a multiplying. The first thing I know is the stopping distance varies directly as the square of the speed. So for that first equation, I know I'm going to need an exponent of 2. Square implies exponent, not radical symbol like square root b, and would be. So I'm going to get d equals k times s squared. The distance varies directly as the square of the speed, and that's an equation that represents that perfectly. Numbers are going to get big. I said round to 1 decimal place if needed, so implies I probably want a decimal answer as opposed to a fraction. Now I'm going to use the numbers in the second sentence. Car traveling 40 miles per hour, that's the speed, so I'm going to go 40 squared. The exponent could be in or outside the parentheses, has a stopping distance of 200 feet. So I'm going to solve for k. I'm going to square the 40 and get 1600. So I get 200 equals to 1600 k. Now I'm going to divide both sides by 1600. And I'm going to get a value for k. It's going to be a fraction. I'm comfortable working with that fraction on this calculator. So I'm going to go 200 over 1600. And I get 1/8 for k. So I'm done with the second sentence. Now comma. I'm done with the first group of numbers. I'm going to the second group of numbers. Find the stopping distance. I'm finding the d, the stopping distance of a car that's traveling 15 miles per hour. So what I'm going to do is I'm going to solve for d. In for k, I'm going to plug 1/8. And in for the speed, I'm going to put 15 miles per hour. This I don't care to do without my calculator. So I'm going to do this all on my calculator. So I'm going to go 1/8 for k times 15 squared, and it gives me 225 over 8 feet, and that's okay, but that doesn't really have a lot of meaning to me. But that's the stopping distance in feet. But if I hit the SD button, it gives me 28.125 feet, and I said round to 1 decimal if needed, so 28.1 feet would probably be better. So the stopping distance, and you could use the fraction answer, but I'm going to use the decimal answer, and my distance is in feet. '26 is the last even problem in this section. Same deal. I look at the first sentence. I look for the words directly, inversely, or jointly. I see the word directly, so I know in this problem that it's going to be a multiplication, not a fraction, because inversely is the only one with a fraction. And then I start looking for words like square, square root, cubed, cube root in that first sentence, of which I don't see any of the words square, square root, cube, or cube root, so I know I don't need any symbols other than the letters in the problem and a k. So the equation I'm going to get is t equals k times I for the first sentence. And then the second sentence, the $42 is a tax, so I'm going to plug in 42 for the t. And 1,500 is the income. I'm going to plug in 1,500 for the income. I'm going to solve for k by dividing both sides by 1,500. And I'm going to get a nasty number for the k. 42 over 1,500 is 7 over 250. I'm going to leave it as 7 over 250 because my calculator does fractions so well I don't care that the answer for k is a fraction. Done with the second sentence, into the third. I want to find the tax t. for the monthly income of 2,000. So I'm going to take 7 over 250, plug it into my equation for K, and plug in 2,000 for the income, and I'll find out the tax by just doing this computation. Again, my calculator does fractions so well that I don't care. I have an ugly fraction here. So it's 7 over 250 times 2,000, and I get $56 for my tax. So my tax equals $56. So that's the end of this chapter. You should definitely try to do all the odd problems in section 3.5 and get real comfortable with them, because there definitely some of these are going to make their way onto the test. And then once you get done with 3.5, you might kind of study like you're studying for the test, and then do the review. And after you complete the review, watch my video for the review. So you shouldn't do the watch the review video until you try to do the review. Treat the review like it's a test. If you could do well on the review without watching the video, then you're probably going to be ready for the test. If there's bits and pieces of the review that you're stumbling on, then you might have to go back and relive those sections, because anything on the review could come on the test. When I do the review, I might make some comments about things that are more likely or less likely to be on the test. But if something is on my review, it is absolutely test worthy. So you should definitely make sure you can do the whole review. Alright, so my computer network isn't up. Hopefully when I send this, it records.